Bismillahirrahmanirrahim. Assalamu alaikum, dear student. My name is Dr. Muhammad Adnan Asgar, and today we will learn how to build multiplication table under the subject of symmetry and magnetochemistry. We have discussed some of the examples like ammonia and water molecule to find out the different symmetry operations and elements in these molecules, and moreover we have already built the multiplication table for both of the molecules. So here in some of the general rules which are going to be very important if you want to draw, if you want to construct the multiplication table of different molecules. So I would like to repeat or recall the rules for the buildation of multiplication table. So first one is actually the product of two members, and square of any member is also a member of group. It means that if here the member mean the symmetry element or the symmetry operation that exists in that particular molecule. So if we multiply the product of the two members, multiply two of the symmetry elements or operations, or we take the square of the any symmetry element or the symmetry operation, then the result would be the same, because the result should be from the symmetry elements or the symmetry operation of that particular molecule. So it should not be beyond the symmetry operations. The B is there must be an identity element. We have discussed the importance of identity already. C, combination must be associative. Associative means if we multiply A and B along with C, then it should be equal to A and BC. And the last one was every member must have an inverse, which is also a member, that is A into A minus 1 is should be identity. And the identity, if A is a member, A minus must also be. So these were the four different rules to construct the multiplication table of any molecule. Here is another example, trans-2-butene. So first of all, for the construction of multiplication table of any molecule, we have to write down the complete set of symmetry elements as well as operations. So students, let us find different symmetry elements and operation in trans-2-butene. We have already discussed that there is identity in all kind of molecules and all kind of objects present in the universe. So we should write identity for trans-2-butene. E. Next one is the proper rotation. So we need to find, is there any kind of proper rotation that is present in this trans-2-butene? Yes, you need to find. There is a C2 here. If we just take this point as the axis of rotation for trans-2-butene, then there would be a C2 in this molecule. So we can easily say, if we rotate this molecule from this axis of rotation clockwise or anti-clockwise, the results would be the indistinguishable. If the results are indistinguishable, then it means this is the symmetry element is present in this molecule. So here is the C2 from this axis of rotation. We can rotate this molecule clockwise or anti-clockwise, the result would be the same. So after proper rotation, we need to find any plane of symmetry, which is also known as sigma. So we need to find, is there any plane of symmetry in this trans-2-butene? Yes, you need to think about this. There is a sigma. Yes, there is a plane of symmetry in this molecule, and moreover we need to find any kind of inversion or improper rotation in this molecule. So there is no improper rotation molecule in this uh, there is no improper rotation in this molecule. So let us find about the inversion center. Is there any kind of inversion center in trans-2-butene? Yes. We know that inversion center was a point in a center of molecule from which if we travel in any direction and we find, for example, I would like to travel in this direction, and if we find any atom or molecule, the similar atom or molecule should be present on the directly opposite side of that point. So if this is the point, middle point of the molecule, and we found the hydrogen over there, and on the exactly opposite side there is another hydrogen, same is the case with the methyl group on the opposite sides, so we can set there is an inversion center also. So far we have find uh, four symmetry operations in this molecule for identity, C2, sigma, and inversion center. So this is all about that symmetry operations and elements in trans-2-butene. So let us talk about an other similar type of example which is quite related to the trans-2-butene, which, and it is the trans-1,2-dichloroethylene. So this is the trans-1,2-dichloroethylene. We need to construct the symmetry multiplication table or symmetry table for this trans-1,2-dichloroethylene and for the trans-2-butene. So for this we also need to find out the possible symmetry operations and elements in this molecule. I do believe that you people are now quite good at to find out the complete set of symmetry operations in any molecule. So I would like to give a quick reply for trans-1,2-dichloroethylene. So here is the symmetry elements which is present in this molecule: identity, C2, sigma, and inversion center I. So these are the total four symmetry elements which is present in this molecule. If you look closely, then you can observe that these are the symmetry elements which is also present in trans-2-butene. So both have similar symmetry operations. Why not we go for the three-dimensional structure of trans-1,2-dichloroethylene for the better understanding of the structure of this molecule. Here I would like to type trans 1,2-dichloroethylene. So herein I would like to write the symmetry elements. Yes, here we can see. I have already told you that there is a website named as chemtube3d.com. It provides us quite comprehensive structural description of most of the molecules. So here we can see that there is actually the C2 proper rotation which is present in this molecule, and actually this is the point of axis point of rotation, and if you rotate this molecule from this axis of rotation to clockwise or anti-clockwise, the results would be the same. And the second one was the sigma which was present in this molecule. I have already told you that there are three types of plane of symmetries that can exist between the molecules. The plane of symmetry may be sigma v or vertical, and sigma h horizontal, and sigma d dihedral. So in this molecule there is sigma h because sigma h was the horizontal sigma, and we know that actually this is the axis of rotation here towards you, towards the observer, axis of rotation, and perpendicular to the axis of rotation there is a sigma. So if there is a sigma perpendicular to the axis of rotation, then that sigma would be known as sigma h. And here we can see that there is a sigma h in this molecule. Yes, exactly, we can observe the sigma h quite clearly in this molecule. This is the sigma h, while the C2 rotation axis is just perpendicular. Yes, here we can see that this is the C2 in this molecule and the sigma h. What about the inversion center? We know that the inversion center is actually the if we draw a point in the middle of the molecule. For example, this is the, we know that C2 rotation is actually the middle of the molecule, and we need to move in any direction, and subsequently on the same side, if we found the same molecule or atom, then there is inversion center. Now this is all about the symmetry elements which were present in this trans-1,2-dichloroethylene. So here is the complete set of symmetry elements and operation that is found in trans-1,2-dichloroethylene, as well as the same symmetry operations can also be found in trans-2-butene, that the last example we have discussed already here. So let us construct the multiplication table for these two molecules. Before going to construct the multiplication table, we should have to write the product of any operation that is going to be observed and that is going to be written in the multiplication table. So we should have to remember the products after applying specific symmetry operation to that particular molecule. It is very important to draw the correct multiplication table for any molecule. So here is actually the products of different symmetry operations in trans-2-butene, as well as this is same for the trans-1,2-dichloroethylene. So here we can see this is actually the sample or the reference molecule trans-2-butene, from where I just put a arrow or upper side arrow to this hydrogen. What happened if we applied C2 axis of rotation to this trans-2-butene? Yes, we know that this is actually the axis of rotation, and towards the observer, if we rotate this molecule clockwise or anti-clockwise, the result would be same. This hydrogen will replace that hydrogen, and this hydrogen will definitely join the position of the first hydrogen. So we can see that actually this hydrogen will join over there, and the arrow position should not be changed because this is actually the axis, C2 axis of rotation, and the product after applying C2 axis of rotation would be the like this one. So we should keep in mind this product after applying C2. Now let us talk about the sigma, which is actually sigma h, and we know that sigma h is actually the sigma which is horizontal to the axis of rotation. So if we talk about the sigma h, the arrow position change downward but on the same hydrogen atom. So it is not change the position, but it change the direction, only direction. So it changed from upward direction to downward direction. So if we get the product like this one, then we can say this is actually sigma or sigma h operation. What happened if we applied the inversion center to the molecule? We know that the inversion center is actually the traveling of distance from the middle of the point of, to any atom, and if we found the similar atom on the other side, the result would be the inversion center. And if we just travel to this molecule here, and we should go for the other molecule downward like this here, So we can set the inversion center would the arrow would be on the opposite side but downward direction. So this is the result of inversion center. Now let us talk about the multiplication table of trans-2-butene. Herein I have already written the symmetry elements E, C2, sigma H, R sigma and inversion in tabular form. Let us multiply all the symmetry elements with different symmetry elements on the upper side. So we should have to multiply the first symmetry element to all the symmetry elements written on the above side of the table. We should have to apply identity with identity. The result would be the identity, and the identity then C2, the result would be C2. Identity with sigma, the result would be the sigma. Identity with inversion, the result would be the inversion. We already discussed that if any operation multiply with the identity, the result would be the same. That is, the operation should be written as it is, because identity is actually doing the name of doing nothing. And here are the results of the first multiplication of identity with the rest of the symmetry operations of trans-2-butene. Now let us talk about the of multiplication of C2 with the all the symmetry operation of trans-2-butene. So what would be the result if we apply C2 with identity? What happened? We should have to apply the C2 then identity. The result is C2 again, because any operation which is multiplied with the identity is actually the same of the that particular operation. So here we should have to write the C2, because identity means nothing. So what happened if we applied C2 and again C2? So we should go there and observe what will happen. If we applied C2, the arrow on this hydrogen would appear over there, and the hydrogen subsequently change the position here. This would be the result. What happened if we again apply C2 to this molecule? This hydrogen will definitely join there, and subsequently the arrow on the upper side should also with the this hydrogen atom. So this hydrogen atom should occupy the place over here, and the with upper headed arrow. So if we get like this structure, then we can say this is actually the identity which is already we have written as a reference. So here we can write C2, and here we should have to write identity, because if we apply 2 times C2 to trans-2-butene, the result would be the reference one, which is identity. So this is quite tricky. What happened if we need to apply C2 for to trans-2-butene, then we need to apply sigma H. What will happen? We should have to apply C2 first. The result would be like this one. And what happened if we apply sigma H? Sigma H was a sigma horizontal, in which arrow on the upper side would appear arrow on lower side but on the same position. So what happened if we apply sigma H over there? The arrow on the upper side would appear on the downward side but on the same hydrogen atom. So if this arrow appeared downward, then this operation would be equal to inversion center. So here we can write inversion center in the third row, second row, but in the third column. Same what will happen if we apply C2 then inversion center? So let's go over there. This is C2, and what will happen if we apply inversion center? So first of all, we need to look at the inversion center. We know that if this is the reference molecule, we applied inversion center, this arrow will appear opposite hydrogen atom but downward. So this should be done with this molecule. So after applying C2, then we need to apply inversion center to C2 operation. What will happen? This arrow will appear over this hydrogen atom, on this hydrogen, but on opposite downward direction. So the opposite downward direction would be the result of sigma h. So we better to write sigma h over there. So here we should have to write C2 identity, inversion center, and sigma. Here are the results. We can clearly see that we have discussed, and actually we found that results from our practice for the buildation of multiplication table. Now let us talk about the third symmetry operation, which is the sigma h, or we can simply say sigma. What happened if sigma multiply with the identity? The result is sigma, because identity is nothing, is actually doing nothing. So if we doing nothing and sigma, then the result would be the sigma. What happened if sigma is applied to trans-2-butene? Then after applying sigma C2, what will happen? Let's go over there. We need to apply sigma first. If we applied sigma, the result would be like this one. And after applying sigma, we should have to apply C2 rotation. Then this hydrogen will definitely go over there, but the position of the arrow did not change. So if the position of the arrow did not change, but the position of the hydrogen of this one is over there, then this result would be equal to inversion center. So we can set this, we should better to write a inversion center over there. And what happened if we apply sigma 2 times? That would be equal to identity, because we know that if we are applying the similar operation 2 times, the result would be the same, and which is the identity. What will happen when we applied sigma and then inversion center? Let us go. First is sigma, then inversion center. Inversion center, we know that this is for the reference. In inversion center, this molecule, this arrow will appear on the opposite side but downward. So what will happen if we apply sigma then inversion center? This arrow will appear on the opposite side of hydrogen but upward. If it is downward, then change into upward, and it is if upward, then change into downward. So this would be equal to actually C2. So we can write this here. We can say this is actually equal to sigma, this is actually equal to inversion center, and third one equal to identity, and the fourth one is equal to C2. And here we can see this is the buildation of multiplication table of trans-2-butene. So let us talk about the last symmetry operation, which is inversion center. What will happen if we applied inversion center then identity? The result would be the inversion center, and we know it quite clearly. What will happen when we applied identity inversion center to trans-2-butene and then C2? So we better to go to see what will happen when apply inversion center. The molecule, the product would be like this, and then C2, what will happen? The C2, if we applied the C2 from this axis of rotation, this hydrogen will appear over there, and the position and the direction of the arrow would not change. So it would appear over there, and this result would be equal to sigma h, or simply sigma plane of symmetry. So we can write over there, here we can write inversion center and sigma for this molecule. The third One is first we need to apply inversion center, then sigma. What will happen? Inversion center, the product like this one, and if we applied the sigma, the arrow would show on the upper side, and if the arrow on the upper side with the upper direction over this hydrogen atom, then this result would be equal to C2. So we can write C2 over here, and inversion with inversion is equal to identity. So this is the complete multiplication table of trans-2-butene, and we can easily construct the multiplication table for any of the molecule. This is all about this. Thank you very much.